Good morning, everybody, and thank you for joining us this morning on this beautiful Thursday, the last Thursday in July. And if you're from the Northeast, you're not liking that. As we know, in fact, Ross being from Chicago, the fall is right around the corner, but we'll worry about that in a month or two. You may have noticed as the slides were scrolling there, we are getting better at posting our schedule in advance. So all of the August sessions are already up, and they're either on. You can either do the direct link that you saw on the slides, or you can go to the Pragmatic Works website, hit webinars, and you'll see for all the sessions that we've done, you'll see the word recording, and for all the sessions that are out there to be scheduled, you'll see the word register. So you just simply have to click the register button and register for any of the sessions. They're all in the one spot now. Make it easy. So we're excited. The community's growing, by the way, tremendously, and thank you for sticking with us, and hopefully we can continue to bring some fresh content. To that end, we have Ross LaForte with us today, and this is a great guest. Ross, many of you might know Ross. He's been in the SQL Server community for how long now, Ross?
About 20 years.
About 20 years. I think I was I was in my freshman year of college at that point. But anyway, so Ross joins us from Microsoft. He runs the MTC in the Chicago Center for SQL Server. He's also an author or co-author on the SQL Server 2008 book that you see there in front of you. And we're excited about today's session on high availability and disaster recovery. So without further ado, I'm going to go ahead and just launch a couple polls, as we usually do, to help Ross get a sense for the audience and what type of stuff he can help you with today. The first question we have here, if I can get this to manage properly, hold on, one moment, is, hopefully you can see this. Are you currently using SQL Server for mission-critical applications? It seems to be growing quite a bit in the last 10 years or so, where people are starting to see SQL Server and use it on those line of business applications. And Ross is interested in knowing how that is in your world. If you can help us out there, that would be great. I'll leave that up for just a second or two. And Ross, the numbers look really good so far. It looks like over 60% are definitely and 30% are growing, which is great. But we also have a bias. We are SQL Server Microsoft people in this session, so might be a little biased. I'll leave that up for just another second, and I'll tell you what, I'll go ahead and close that. I know we want to get started. Ross has a great presentation. I'll share that information with you. Looks like about 60% of you are definitely using it on Mission Critical, and it's growing, which is great. So hopefully we can help you today with that. We have one more question for you, and that is more in line with how we can help you today. What type of excuse me, not HR, that wouldn't be good, HA and DR solution are you currently using for high availability?
Really?
For those of you who do have HR problems, this is not the place to talk about them. And you can see the poll results there too, Ross, as they come in. Huh? Okay. Great. Looks like most of you are using everything or backup and restore. All right, we're up over 80%. So I'll go ahead and close that and share it with all of you so you know how you're doing with your colleagues. And hide that. And Ross, what I'll do is I'm going to switch the screen to you. And I'll stay on with you until we can see your screen, and then it'll be all yours. Okay, yep. Where is that, by the way? Yeah, where's your desktop? Is that France or Germany?
My desktop?
Yeah, the nice bridge with the beautiful house.
Oh, I don't know. That's just a wallpaper.
Oh, okay. All right. All right, it's all you, Ross.
All right. So my name is Ross LaForte. I am an architect at the Microsoft Technology Center in Chicago. So primarily my focus here is to build solutions around, or help customers develop solutions around SQL Server, all the SQL Server products, including HA and DR. Okay, and that also includes BI and everything around that. So I've been with the Microsoft Technology Centers for over 10 years. So I see customers here all the time and with all different challenges that I work through. So in addition to that, like I said earlier, I've been in this area when it was in the Sybase days before SQL Server actually became SQL Server. So about 20 years. And so I've seen a lot of different customers, a lot of different challenges, and worked into a lot of different solutions. Also, I'm co-author of SQL Server 2005 and SQL Server 2008, Rocks Press SQL Server administration books. And in addition to that, I also teach part-time at DePaul University and SQL Server administration. So one of the areas that I tend to focus around a lot because I get a lot of requests, and typically that's why we focus on certain things, because we get a lot of requests from customers to in those areas, is high availability and disaster recovery. That's a very common theme. So I've done a lot of opportunities and build solutions, and some of the solutions I'll be presenting here are solutions that I have built, case studies that I've actually built myself with customers. Okay. So to start, what do we need high availability? You know, just downtime causes lost customer revenue and decreased staff productivity. For example, when I run the customers that are in trading especially, or let's say airline, I mean, just an hour downtime for them is huge amount of loss and business opportunity. So that so it depends on different organizations have different requirements, and then and also different applications have different requirements as well. You know, some applications are more mission critical than others. Okay, and so we have different solutions and different variations of these solutions to meet those needs. There's two types of downtime. You're gonna have planned downtime, you know, to do patching, service packs, installations, or hardware upgrades, things like that, maintenance. And then there's unplanned downtimes. You know, things happen and system goes down and you need to recover. So you're gonna kind of have to handle both situations. Okay, and one of the things I get asked often a lot is customers saying, well, I want 99.999% of downtime or a variation of that. So if you look at these numbers, okay, as you go to more nines, it gets more and more challenging to meet those because I mean, if you're looking at 99.999, you're actually looking at a 5 minutes and 26 seconds of downtime a year to achieve that. So, and all these are possible. But to achieve, as you go higher in number nines, the cost differential to get there gets a lot higher, much higher. It just exponentially higher. Okay, so oftentimes we look at all these solutions with customers, and then they kind of settle down on something that is affordable and then meets their needs. And one place you could start to identify what those needs are is the recovery time objective and the recovery point objective. Okay, so RTO, allowable duration that an application can be down. Okay, how critical is the application? Some applications are more critical than others and may require you to actually put more systems and more processes in place. Others, are not as critical, could be down for a longer period of time. Recovery point objectives, the amount of data loss the customer can tolerate. Okay, so the more, if you can tolerate no data loss, you probably have to put a lot more resources and capabilities in place to achieve that. And if you could afford to to take some loss, and you probably don't have to. And we're going to talk about different solutions and different variations of these solutions that could actually achieve that. Okay, and what customers have done to achieve that. So in general, what we're going to talk about is these four different SQL Server high availability solutions to apply for high availability and disaster recovery. And then we're going to do variations of these. Okay, it's going to be a combination of these. It's going to be a variation of these. It's going to have SYN, connectivity to make some of these possible. So we're going to start with the four basic building blocks. Okay, database mirroring. Transaction replication, which it also includes peer-to-peer replication. log shipping, which has been around for a long, long time, and it's very basic process commonly used with DR, and Windows clustering, and also form a Windows clustering called geographically dispersed clusters, which some of our customers have implemented as well for the disaster recovery. So starting off with data mirroring, first I'll start you, we just kind of get everybody on the same concept and understanding, and then we go through the 5 different case studies that customers have implemented these solutions. So database mirroring is kind of like you basically set up a hot standby that protects the database or server failure. And the database mirroring, what it is, it actually came with SQL Server 2005. It actually creates a separate copy of your database. You have a separate database somewhere else that every change that happened in the primary, okay, is replicated to the mirror. Every change, as changes happen, gets replicated. Okay, it's kind of pretty easy to set up and everything. It's 2 separate databases, so if you lose one, you have a complete copy somewhere else. It does have the log stream is compressed. Okay, so you do have compression built in. So as far as you make changes go across the network to the other server. They do get compressed, so you actually reduce amount of network traffic going across of it. And especially that's important is when you do database maintenance. If you think about database maintenance, when let's say you do a database you reorganize an index or something like that. Those type of operations do actually transmit a lot of changes across the wire, and those are the areas where, especially having compression really helps. So, we have a very active systems. Compression is going to really help a lot in those areas. Also, what database mirroring gives you, which log shipping doesn't, is the automatic transparent client redirect. In other words, if the server fails over, the clients will fail over to the other server along with it. Okay, which is nice. So you don't have to worry. You don't have to even worry about having to have any manual intervention to do that. Okay, like I said earlier, it's 2 separate copies of data, separated, and it could be very far away or very close together. Okay, they just have to be able to see each other. Okay, and the log stream is compressed. So the way it works is there's 2 ways that mirroring works. It could be synchronous or asynchronous. So if you set up in synchronous mode, okay, which means is that any change that happens to the principal must happen to the mirror before the client gets acknowledgement that it's complete. Okay, so a change happens so a client makes a change to the principal moves that change to the mirror as part of the same transaction, and then it comes back and says, I'm done, and the client continues on. So synchronous allows you no data loss, but there's also a performance penalty for that. Because what happens is once the change is made to the principal, it has to be transmitted to the mirror, and there's a network latency between the 2. Therefore, the client, since it's part of the same transaction, the client actually sees the performance, the latency as a response time, impact to its performance of the client application. Therefore, when you do synchronous, you either want to have a fast network across the 2 of them, and you also have servers that can handle additional workload that is going to be put against them, because they have to run together. And so what we usually see is customers that do synchronous usually are for very mission critical applications, because they're going to incur the additional cost of the client, of response time that the client sees. Okay, so that's one way to do that. Now, if you're in synchronous mode, you could take the option of having a witness. A witness is like a quorum drive, like in clustering where you have a quorum. It just kind of says if the principal were to fail, you still have a quorum, because the witness in the mirror could form a quorum, and it will promote the mirror to be the new principal. So when you have a witness, then you could actually have automatic failover. So therefore, as the principal goes down, the mirror becomes a principal, the client gets redirected to the mirror. That's synchronous data mirroring. Okay. Then, in addition to that, you could have either asynchronous data mirroring or synchronous data mirroring without a witness. So in asynchronous data mirroring, what that means is that you are making changes to the principal, and the changes are asynchronously getting to the mirror. But if the principal were to go down while the changes haven't made it across, you could have a chance of losing data. What's important about asynchronous is that it also relieves the latency issue that the client sees, where it's not in the same, the change that they make is not, the client makes, is not in the same transaction. It doesn't have to wait for the mirror to commit before it receives an acknowledgement. Okay. So that's why for longer distances or where network is an issue, we typically go asynchronous because of performance issues. Now, if you don't have in asynchronous, if the principal were to fail, the user has to promote the mirror because there's no witness. Okay, no witness to do that. So the administrator has to promote the mirror to be the new principal. Or if you have a synchronous mode, but you don't have a witness, then again you have to manual interventions. So the times where you can get automatic failover is if you have the witness there, okay, and you're in synchronous mode. Okay. The other thing to note about mirroring, it mirrors a database by database, and another thing about it is that it's transaction by transaction going across. Okay. An automatic failover, and the automatic client redirect still happens because I mean the client could still redirect to the other because if it knows he has a partner, even though there's another witness, it would if in the connection string it has a partner, it would try, if it can get to the principal, it would try to go to the mirror. So that will still happen. Now, what also SQL Server mirroring gives you is the ability to actually do checksum to validate pages. So if a page is bad, it's sent, and SQL Server, the mirror receives is bad, it could actually request the same page to be resent again. So that's built into the mirroring capabilities. So it does have error handling. That's mirroring. Okay, and then we're going to kind of put it all together. Transsexual replication. It's high performance latency. There's a little bit of latency, but it is asynchronous always. Transaction replication. So in addition, in a case of mirroring, it could be synchronous, asynchronous. In transaction, it's always asynchronous. You make a change, it flows to the others. Basically, the reason it's minimum load on the server is because it reads off the transaction log. So it really doesn't impact the server overall. Transaction replication or peer-to-peer, which is a form of transaction replication, it basically reads the transaction log and sends us changes. So it really does. It's not really impacting a lot the data or scanning tables. There's no special hardware required for it. Basically, just set up the servers and set up the transaction replication infrastructure. There's two forms of transaction replication. Standard transaction replication, which means it's standard transaction replication read-only. Basically, the publisher makes a change, receives a change, and sends it to the others, to the subscribers. Or you can have peer-to-peer. Okay, a peer-to-peer replication is where everybody's a master subscriber. The publisher receives a change and sends it to everybody else. The other publisher receives a change and sends it to all the others. So everybody is sending changes to the other. The nice thing about the solution is that you could actually, your data resides everywhere. Okay, so if you lose one server, all the other publisher subscribers have the data. Also, the peer-to-peer advantage is that you can write in any one of those nodes. Of course, when you write, you do have to handle conflicts. Okay, because if you do have conflicts, it has to be handled. For example, if two nodes make the same change, well, you have to handle those type of conflicts. Typically, in replication, and when you use replication, you try to avoid conflict as much as possible because they do give you problems, and also performance issues because you have to manage them. You have to solve them. So here's the two forms of replication. Pretty much, publishers in New York and subscribers are New Jersey servers, and they just kind of and basically the New Jersey server will be read only, and New York will be the publisher and read and write server. This is used oftentimes. It could be used for HA, for DR. It could be used also for reporting. If let's say a customer wants to do reporting off of one of the subscribers, okay, so they don't have to impact the publisher and have the publisher do the reporting. So they kind of like alleviate some of the resources needed for the publisher. So, and then you have peer-to-peer, where everybody is sending data to everybody. Okay. So in this case, if you lose London, outside of some data that did not make it to the others because data is moved in transaction replication in asynchronous mode, outside of that, all the data resides everywhere else as well. So you do have copies of all the data. The nice thing about the peer-to-peer also is that if you have a distributed environment where you have large customers that have offices all over the world, you could have the London users using their, changing their data, okay, but have read-only for the other data, okay, and then you have the users in Tokyo changing their data and have read-only to the data from for all the others. So you could potentially have a very well distributed where all the data residing everywhere. At the same time, everyone could actually work and share data. So here's how peer-to-peer works. Data, everybody is a publisher-subscriber. It's a publisher, and also it's subscribers to everybody else. So they move data to others. Okay. Now, what I could say about replication is it does require a little more infrastructure to put in place, but there's customers who have that infrastructure in place and are comfortable using it and use it very effectively in DR. So it's not probably my first choice for DR, but or HA, but I have customers who are very comfortable, have used it for many years, have the skill set for it, and use it very effectively. Okay. In addition to that, there's what's been around for a very long time, is log shipping. Log shipping is similar to mirroring, except it's asynchronous, and instead of sending a single transaction at a time, it sends the transaction log from the primary to the secondary. Okay, so basically, the two sites could be next to each other, very far apart from each other. It's a very easy process to put together and to run, and very easy to troubleshoot. Okay, it's just a few jobs to run it. And optionally, you could have a monitoring server that can monitor the history and the status of the jobs and raise alerts if you run into that. So here's what log shipping may look like. Okay, you back up the transaction log on the primary, and that's one job. A second job copies the data over, and you could compress it along the way. You could actually run some compression algorithm here, and then you, as well as a backup, and it will be compressed, and then you could actually send it across to the secondary servers. The difference between this and their mirroring, why some people choose this versus their mirroring is that their mirroring has a one-to-one relation with a mirror. You have the principal and a mirror. You cannot have one-to-many. In log shipping, you can have one-to-many. So for example, I could have like in one case, I could have a server, a log shipping server that's local, okay, within the same data center. And then I could have a second server that's remote in case that data center were to fail. So I could actually log ship to multiple servers at the same time. And if you have it run into a problem, it's very easy to troubleshoot. There's 3 jobs here to troubleshoot. There's job 1 run, there's job 2 run, there's job 3 run, and basically you determine where the problem is. Very simple to do. Now, and probably a lot of you guys have used this, is Microsoft clustering. Okay, Microsoft clustering is it's been around for a long time. It's a shared disk environment. One difference here is that you have a shared disk. Basically, you have one database. You don't have a second copy of the database. You actually have one database, and your risk is if the SAN were to fail, you basically lose that access to the database. Okay. Outside of that, you do have RAID. Usually, your disks are rated, so which means if you lose a disk, that wouldn't be an issue. The risk with it is, so the biggest risk with clustering is it's just it's the same SAN because you're sharing the same disk in a SAN, and if the SAN where you have a problem with the SAN, you'll be unavailable. The other difference is with clustering, which is different from all the others that I've talked so far, is clustering is by instance, by SQL Server instance. So for example, you actually are protecting the whole SQL Server instance. In log shipping, in mirroring, in replication, you are by database by database. Okay, so there's advantage with that, because if you want to protect the whole instance, very easy to do with clustering. Okay. Also, clustering gives you the automatic failover, just like mirroring does, but mirroring has to be in synchronous mode to do that. And clustering could be combined with log shipping, with mirroring, with replication. And a form of cluster which I've done a lot of work around is geographically dispersed clusters. Basically, you create a cluster across 2 different locations, across 2 different SANs. What that does, it protects you. If a SAN were to fail, the whole SAN were to go down, you have a whole a different SAN somewhere else that could take over. Also, what it gives you is the capability of being able to fail over across sites. Okay, so clustering, generic clustering. Okay, I've done a lot of clustering in my times and helped a lot of customers cluster their environments. You basically have your cluster nodes here. You have a private network here with your heartbeat, which the heartbeat is a way for these nodes to check with each other to determine if anyone is down. So they check each other and say, hey, are you still up? Are you still responding? And then you always want to have some redundancy, okay? Because, for example, you don't want to have a cluster set up, and here you have a SAN, and then you have these fiber channel switches, and you have one, and the switch fails and brings the whole cluster down. So you have some redundancy here. You also want to have some redundancy in the network. You don't want to have the private heartbeat share the same network with the same switch with the rest of with your heartbeat, or even have a single switch, because if that switch fails, everything fails along with it. Then you can't access the cluster. So you want to have redundancy on the network. You want a redundancy on the fiber channel, okay, and you have redundancy at the disk level with RAID groups. Because oftentimes I've run with customers where they take the private network and put it in the same network with the public network in the same switch. Well, if the switch goes bad, well, you lost both. Okay, so you really want to think about redundancy. Okay, and how much redundancy can you afford? Because the more nines you go, the more expensive it's going to get. Because the more hardware you have to buy. And a form of Geo Cluster, and I've done actually quite a bit of these too. And in fact, I actually helped several SAN vendors develop a solution around this, around Geo Clustering. What you do in this case is basically you have a 2-node cluster, a 4-node cluster here, 2 reside in one site, 2 reside in another site, and then you have they have their own SAN in one site and a different SAN on another site. And between the two, there is a SAN replication that replicates all the data from site 1 to site 2. Okay, so from SQL Server and from Windows perspective, this looks like a cluster, just like it looks like a local cluster, because when the failover happens, all the data from site A, it's in site B, because the SAN is replicating the data, and vice versa. So when site B comes up and looks and says, well, I have all the data, so I'm consistent. So it brings up and runs. The nice thing about this is it gives you 8-chain DR both, because if your site A goes down, you got site B. It gives you high availability because you got multiple servers in site A, multiple servers in site B. Okay, and also it gives you automatic failover, because replication, as a virtual IP address will fail over from site to site. Okay, as long as it's in the same network. So this has to be in the same network to fail over, at least in this release. Okay, for SQL, same VLAN. And the way this magic is really done is through the SAN replication. So when I worked with these type of solutions, you always have to leverage the SAN vendor because they have to build infrastructure to be able to replicate all the volumes from one side to the other. Okay. Usually you replicate all the volumes except TempDB. You want to avoid TempDB because TempDB usually is the one that grows, and then when it reboots on the other side, it starts over. So so you don't want to replicate any data there because the data is going to be thrown away anyway. Once site B comes up and restarts, it just recreates TempDB anyway. So what we do is we put TempDB in a separate lung and don't replicate it and replicate everything else. So what you do is when you move over to site B, everything is in site B, and SQL Server comes up and goes on and continues on. So as far as what versions of SQL Server and what they can support as far as clustering. With SQL Server Standard, SQL Server can support up to 2 node clusters. With Enterprise, you can support up to 16. So you can have up to 6. So you have a node of 16. Usually if we have a node and it's larger than 2, or it usually is we set up like n+1, which means is there's always we typically set up a passive node. Therefore, because if you have 8 or 16 type of nodes running, you want to have a node that could take on some of the load, because that's a lot of load to spread around. Now, if you have, let's say, so for example, if you have 16 node, you have 15 active, and 1 passive, or something like that, or 14 active and 2 passives. So the passive could take on the load if you want to meet certain SLAs. If you try to keep everybody active, then what you really want to do is you want to make sure you leave enough headroom on those nodes that if a failover happens, the remaining nodes could actually take over the load and run and give you a reasonable SLA for your customers' needs. Okay, so when you look at all these different solutions, you can really all put it together and build a combination of these and build your HADR. Okay, you could have local clustering. Okay, of course you have backup. You always have backup. You could have mirroring for hot standby. You could have replication for hot standby, for scale out, for reporting, for a separate copy of the database. You could actually put it off, mix and match together. You could have log shipping for warm standby, cross locations. And also we have customers who like this very much. You have log shipping with restore delay. So for example, saying that I want to delay for an hour my restore on my secondary. Therefore, if I find a problem in my primary, and the primary happens, and let's say somebody calls a problem, deleted some data, I actually have a secondary that's an hour behind that I can actually use to restore the primary again. So you could actually, let's say, log shipping, you could actually back up the transaction log, copy it over, but don't restore it. So you could mix and match. You could have clustering, local, replication, mirroring to a DR, log shipping to DR. All these are possible to be put together to build your HADR solution. So, so one more slide before we get to the case studies and case studies of things I've done with customers, with the customers' engagements, is typically in SQL Server high availability licensing, you don't license a passive node. Some people know that, some people don't. So basically what it says is that if you have log shipping and you are not using the passive node, you're not using the secondary, you don't have to license that. You only have to license if you're using it. Okay? In log shipping, you only use it, you could potentially use it for reporting. But for example, if you're using it, you have to license it. If it's just passive, you don't have to use it. If you're in clustering and you don't use the passive node, you don't have to license it as well. Okay? And that's kind of things that, so it becomes very cost effective. You don't have to buy another SQL Server license for the passive node if you're just going to use it for in case of a failover. Okay, with that, I will transition into what I've done with some customers building solutions, and kind of high-level solution, mission-critical solutions. So one of it is care group healthcare. Okay, as you can see here, care group manages a number of hospitals in the Boston area and has 390 databases, 146 mission critical, and about 2 terabytes of data. What we built for them was local clustering. So we have a clustering in one location, a cluster in another location, in the DR location. Okay, and then we built data mirroring across 2 locations to keep it a DR. So we have HA local in both sides, and then we have mirroring to do DR across them. Okay, so like I said, you could mix and match these. And the way they looked at it too was they created. Remember when I said the data mirroring could be synchronous, asynchronous? They looked at their RPO and RTO numbers and said, okay, I could classify some databases to really require 0 data loss, and some databases we could sustain some data loss and still be okay with some databases. And some databases have to be online all the time, RTO, and some we could incur some downtime. So based on that, they classify that. They determine which ones should be in synchronous mode mirroring and which one could be in asynchronous mode. Okay, and so they set their standard and classify which database, because remember that in synchronous mode you do incur a lot more network traffic, and the network because of latency, and the user actually sees that as response time, because the latency going from DR site 1 to DR site 2 is response time that the user incurs. So they looked at that way. And the other thing they also looked at was, in mirroring, as you fail over, because in clustering, if they were in cluster, let's say they fell over across the same site, clustering takes care of the virtual IP address. But if you're going across the sites, they need to be able to fail over the clients. Now, in mirroring, you could actually tell the client in the connection string you could put in of the application, you could put a partner so that the application checks the primary. If the primary is not available, it checks the partner. The problem with that solution is if you have third-party applications, say application you purchase that you haven't built, that would be kind of hard for you to actually go back and change and make a change to them and put a connection string into them to do that. So in that case, that wasn't really feasible for some of their applications. So what we did, we used DNS to redirect the clients from one site to the other. So for example, if the DR site was to, if the principal site were to fail, if the DR site 1 were to fail, we would just kick off a DNS script to point everybody to DR site 2, and then the clients will all go there. Okay. The one point to make about this solution, and one catch you have to worry about is that in addition to synchronous, asynchronous, and automatic failover, a third thing is mirroring has a partner timeout. So for example, based on the time, it determines if it needs to fail over. You have to make sure that the timeout is greater than clustering timeout. Clustering time, clustering time to recover to fail over. Okay, because what you don't want the cluster, something happen locally. The cluster, one node, the cluster goes down and recover on the other, but the mirroring timeout is being smaller than that, determines that the whole site is down and moves everybody over. You want to make sure that the mirroring timeout is greater than what it takes for the cluster, the local cluster, to fail over to the other node. Okay, otherwise you're going to have failovers happen unneeded. Okay, that is one solution that we worked on. This is another solution. This is a solution I'm also very familiar with, and it's a very big solution, and it actually runs very highly available. Okay, so BWin is it's an online gaming company that provides game and sporting betting, and they do about 1 million bets per day, over 90 sports, 100 terabytes of data, Okay, 850 databases, 100 SQL Server instances, largest database 4 terabytes. Okay, and they could have peaks of 450,000 transactions per second. Okay, in this type of environment, also you can't afford to go down. For example, if you go down, there's a quantifiable data business lost. Okay, because customers can bet. Okay, so in this case, what they did is they created a mirror from the principal to the data center A to data center B. Okay, they did a mirror, and then they also created a log shipping with a 1 hour delay. So, like I said before, you could create if you put a 1 hour delay, what it gives them is the ability to say that if I get some sort of error, if I found out there's a problem, this is an hour behind, I could recover the database back to that 1 hour. At the same time, I have data center A and data center B completely in sync. Okay, running in sync all the time. And so in these cases, the two data centers are 11 kilometers apart. Okay, and they basically implemented it all on top of database mirroring. Okay, and they get their highly available using this configuration. In addition to that, they get also the mirroring gives them the log stream compression between the two sites. And, so it compresses the traffic runs to the sites. And they also get auditing, which they were looking forward to get auditing, and they get backup compression. Okay, that's B1. Okay, here's a third one. Okay, this one is a Geo Cluster implementation. So these two sites, this is a rail transportation logistics company. 1,000 train services a day, carrying 170,000 passengers and 683,000 tons of freight. So what you see here is that you have two Hitachi sands, and you have a cluster here and a cluster here, and these are SAP sites. What they did is they have a local cluster, so they could fail over locally, and a DR site. Of a single cluster, a single node here. Okay, or you could also have a 2-node if you wanted to, but they implement a single node here. And what they do is they use Hitachi SAN mirroring to mirror all the databases from here to here. So this looks like as one cluster, as far as SQL Server and Windows is concerned. Okay, and you can see there's multiple switches because you want to have some redundancy. Okay, and if this was to fail, all the data, because of the SAN replication, it would live here. And once cluster fails over, usually what happens, without getting a lot of details, what happens is that when a failover happens, you will usually put a script in the cluster to promote the site to disks, so that the secondary, the node here, could become active and start running the business. So mirroring, and this could be across distances. Okay, in this case, it was 5 kilometers apart, and the two disks were mirrored synchronously. So again, when you do synchronously, there's incur some cost because all the data has to make it to the other side. So you do want to have a good network traffic, good network pipe between the two of these. If you do asynchronous, you have a chance, and you may not want that, depending on your RTO and RPO. You may have a chance to lose some data that's in transit otherwise. And the next one we're going to see is just it's not geo-clustering, but it's but actually did actually implement asynchronous. So in this case, if site 1 were to fail, the clients will automatically, through the virtual IP address, will be directed to virtual IP to site 2 directly. Okay, this is another one that I worked on. I helped. This one one of the ones also I designed. It's for Progressive Insurance. Okay, and it's a large auto insurance in the United States. Okay, they have this application, this was to run 30,000 independent insurance agency. This application. Total data size was 10 terabyte, largest table, 2 billion rows. In this case, what we did was we created a local cluster and a second local cluster, and we used EMC SAN to replicate between the two clusters. Okay, so, and this was something also we didn't know if it was going to be possible. It was something actually, we didn't know if we could actually replicate across two clusters and things, and the second cluster would be happy to receive everything and nothing, because we didn't know if there was any dependency. So we've never been done before. But we tested this out and worked out well. Basically, we actually took all the data from the data center in Ohio and replicated all the way to Colorado. Now, because these are so far, very far apart, okay, we actually needed to run in asynchronous mode. So in this case, we ran asynchronous across the two. Because in synchronous mode, from Ohio to Colorado, the people there in the U.S., it's quite a distance that you will really need a very fast network in order to support synchronous. So the customer was okay with, and in this case, Progressive was okay with a possible data loss if needed, if it happens to have a data loss, The other thing we did here, which is not really shown in this diagram, is this really was a three-way mirror, not a two-way, it was not really a two-way mirror like it's shown here. The data from data center 1 was mirrored to data center 2 in the SAN, and it's asynchronously going continuously doing that. And then we had a third mirror that we did a snap disk to from the second mirror to bring up the SQL Server on the secondary, on the Colorado data center. The reason we wanted to do that is, so for example, if we wanted to run DBCC checking against the mirror, if we only had a two-way mirror and data center 1 was active, that the second mirror 2 would not be accessible because it would be written by the data center 1 in Ohio. So that would cause we would have to then shut off the mirror in order to bring up the cluster in Colorado. By doing the third mirror, we just do a snap disk every so often, bring up the mirror up, run DBCC, we could run backups on it, we could verify the SQL Server is up and running, everything looks good, we could do service pack updates, and then bring it down. And then if we want a newer copy, we just snap the second mirror with the third mirror and bring it up again. Okay, and also that gives us a comfort feel that SQL Server in Colorado is good and running and everything looks good. In addition to actually we move the data, we even when we do service, we validated we could actually do service pack updates on both sides, and the data replicates across and it also works fine. The data comes up. The changes that were done by the service packs on Ohio replicates to Colorado, and because the binary on Colorado will be upgraded by the service pack, just like they did in Ohio, it would actually come up just fine with no problems. So in this case, we have two clusters, so and replication between the two clusters. The network between these two nodes was 2.5 gigabytes per second. Okay. Okay, that's one I also have experience with. Here's another one, peer-to-peer replication. So here's where usually people, they use peer-to-peer, and I've also seen customers use this for just DR in general. But replication does require a little more work to set up. But if you're comfortable and you're a customer that have used replication a lot, and some have, and they're comfortable with that environment and managing that environment, they could use it, and it makes a good DR environment as well, even a HA environment. So this is a company in Asia, fastest growing provider of online hotel reservations. And what they did is they actually created a peer-to-peer replication where sites, different sites, American sites and Asia sites, were actually replicating to each other. So for example, any changes in America will replicate to the other sites. Any changes in the other sites will be replicating back to the others. So everybody has data for everybody else. And in this case, it's asynchronous, so there's a little bit of latency. So potentially you could lose some data because data doesn't make it to the other site fast enough, because if the site were to fail before the data actually gets out. But the thing about this is that different customers, different parts of the company could actually be working on their data locally and replicate other data remotely. So for example, you could have the people in Asia working on the Asia accounts, and the US working on US accounts. And if let's say the US server were to fail, well, the Asia account has the data. You could really point to the Asia account, go across. Of course, you're going across the ocean, but you could get to your data going to the Asia server. In addition, what they did is they created additional transsexual replication, read-only copies for data mirroring, for data warehousing, and for read-only copies of the database. So they have peer-to-peer, and then read-only copies with transsexual replication. That's another way to create the RHA. Now, what I'd like to finish it is with a comparison, okay? Kind of simple comparison. And then maybe if you look at the slide, you know, once you get access to the slides, you could probably spend more time to this, because I'll be covering this like 3 slides for all these. If you compare these 4 different options, distances, usually clustering is limited. Even if you do Geo Cluster, it's still limited because of the network latency. So distances between the nodes. Okay, log shipping, pretty much no distances. The mirroring, really, if you're in asynchronous mode, no distances. Replication, again, no distances. Server switch, in clustering is automatic. Log shipping is always manual. And in mirroring, it depends. It's automatic failure or manual if you're in synchronous mode, asynchronous mode, if you have the witness. Okay, replication is manual. Average switch times, okay, that's usually log shipping is more manual, so you may take a little longer to switch. It depends, but also it depends how scripted you are. If you have everything scripted, you can switch very quickly. One big difference is failover clustering protects a whole instance, but also it actually works on a shared disk, so it only has one instance. Versus in mirroring and log shipping and replication, it's by database. But at the same time, it's a different copy of the database. It's not shared disk. So potentially, unlike clustering, which if you lose that SAN, you just lost the database. You have lost access to the database. In the others, you could actually have access to them. So granularity, entire instance. Okay, you actually have the entire instance. This is by transaction, per transaction log, by transaction, and depends on the type of replication. Recovery mode. Okay, I'm just going to go quickly some of these. Failover cluster, you could go up to 16. Log shipping, you could have as many secondaries as you want. Of course, there's a maintenance issue, as you add more and more and more. But as far as a solution, it could support that. Log shipping, mirroring is one-to-one. You can only do a principal to partner. You can have one-to-many. And replication, again, it's unlimited, but again, it's going to be a maintenance issue if you have a lot of them. Okay. Special hardware. In a case of failover clustering, you do need hardware, like a SAN or a shared disk environment. In the others, you don't. I mean, you just need another set of disks to copy the database. As far as data loss, well, in failover clustering, you have it's just a single instance, the same database, a shared database. So you're really not losing any data. In this case, in the others, you're actually moving data from one end to another. So there's a network latency across them. So single point of failure in failover clustering is the disk subsystem. Unless you have Geo Cluster where you have 2 SANs, then you're kind of eliminating that. In the others, there really isn't no single failure because there's really a whole set of new hardware.
Oops, it looks like we might have lost you, Ross. Is there a chance that you hit the mute button? Well, what timing that is. It's the beginning, it's the end of the, unfortunately, it's not going to allow us to get to question and answer. I apologize for that for everybody. But it looks like we might have lost Ross's audio. But we are at the top of the hour. And what I do have is all of the questions here for Ross. What I can do is share those with him after the webinar. We have your contact information, and we'll go ahead and get back in touch with you for each of the questions. Okay, I apologize for that, but here we are at the top of the hour, and I think we lost Ross. So I'm going to leave it open for another 30 seconds or a minute just to see if he can pop back on. But it looks like we might have lost him for the end here. For those of you who do want to hang out, I'm going to try to reach him and get him to dial back in. So that'll be probably another 15 seconds or 30 seconds before he's back, and then we can get to the QA. But we realize it's the top of the hour. So either way, we're going to try to get back on and talk to you in a minute.
In mirroring, that depends. I mean, you could use, just like in log shipping, you could use DNS. You could use what Mirror has built in, the automatic redirection if you have a partner set up on your connection string. Another way to redirect is to use, some people use load balancers.
You're good, Ross. Sorry about that. I was trying to reach you on the cell. We lost a few folks, but we might as well go through. For those of you who do have some time, we'll go through the Q&A as well, Ross, if you don't mind.
And I'm almost done. This is the last slide. And replication is again, there's no server name abstraction. You got to point users to the other. So either way, there's the three ways to do it is to point applications to others is DNS, load balancer, either hardware or software, or in the case of mirroring, to create mirror in the partner. Schema dependencies, there's no except for replication as schema dependencies. Outside of that, I'm done with my presentation, and I'll take any questions that you may have.
Ross, a common question we had before people leave here is, can you make your slides available anywhere? If you'd like, we can post them for download, or is that something you're comfortable with?
Yeah, I'll send it to you and you can post them. Is that good?
Fantastic. So there's your answer, everyone. For those of you who remain, we'll have the slides up next to the webinar when you can view the recording tonight, and then next to that you'll also be able to get the PowerPoints that Ross went through today.
For how long did I lose the audio?
You probably lost it, I'd say, about a minute.
Okay, that's not bad. Okay.
And you know what? It's the end of the hour too. So if there was ever, but what I'll do, Ross, is ask a few questions. We do have some people remaining. Do you mind if I pose some questions to you? Okay.
Go for it.
All right, let's go. This one goes out to, let's see here. A lot of folks have left, so I just want to make sure I'm asking someone who's still here. This one goes to Brett. Is asynchronous available in SQL 2008 Standard Edition?
No, it's not.
Okay.
It's not available.
Okay, that answers that one for you, Brett, if you're still with us. All right, going down the, let's see, Quentin. We'll go to Philip. Can transactional replication occur in DBs that are in simple mode?
In simple mode, the primary database, the publisher is the one that needs to have the log read. The other one's just receiving data. So they don't have to have. They could be in whatever mode. They don't even have to be. See, in peer-to-peer replication, when you have the publisher reading data, that's what you need. You need the transaction log. The others, let's say if you're doing it, if it's regular transaction replication where you have a publisher and a subscriber, the subscriber could be anything. Could not even be a SQL Server. Okay, that makes sense?
That makes sense. Yeah, absolutely. Hopefully that helped you.
At that point, it's just inserting data to it.
Okay. Now, Philip did have another question here that I'll just go ahead. Will Microsoft ever support a real cluster, that is to say, an active mode cluster?
Yes, we are working on that. Yes, that's in our plans.
Okay.
Support that. Yes, it is in our plans, and I can't tell you when, but it's in the plans.
Okay, this one's for Saeed. Saeed, I recognize that name. Thank you for joining us again. Saeed has a principal mirror and witness server on SQL Server 2005. In mirroring monitor shows connection issues and both DBs are stuck in recovery mode. How do we resolve this issue? Any suggestions?
They're stuck in. They're both stuck, and both the principal and the mirror are stuck, and neither is taking connections.
Yes.
Okay, so if they're both stuck, we probably have to. I would probably need to know. You probably need to look at the logs and see why they're stuck. What's causing them to be stuck? Because I mean, you got to do some troubleshooting. It's hard to say what's causing it to. For one to not recover, not the other, and neither of them to recover. Yeah.
Oh, okay.
You got to do some troubleshooting.
All right, Ross. Another question we have here is.
Just one more thing.
Yeah.
The book that our book does have a troubleshooting section. If you happen to have the book.
Okay, and that book, I know I have it on my screen here. Do you happen to have the contact information? That's another question here for folks in the audience. Is there a way for them to contact you, or?
Sure. I put it on my slide. What about I put it in my slide?
Perfect. That'd be great. And I don't know, Ross, do you have a blog or anything like that you actively?
No, not really.
Not yet. Okay. All right. You might want to do it on BIDN, by the way. We have everybody on BIDN. Moving forward a little bit. Okay, let's go to Natasha. How do you handle reporting when the subscriber is being updated? Do clients get kicked off?
Are we talking about replication or which one?
Let's see here. Natasha, if you can clarify, I'll look for your response.
It makes a difference.
Okay. Yeah, she didn't mention it. But Natasha, if you can clarify, I'll go ahead and pick your name. Replication.
Okay, replication.
Yep.
So if you're doing replication, reporting it's really not impacted with replication. Unlike the other solution, that's why I asked which solution. In replication, the subscriber is receiving updates from the publisher, just as if it was another client, another user. So you can do reporting at will. It's just taking locks, just like our users taking locks. So there's no issues. We don't have to kick anybody off. It would just work online with everyone else, with the other users. Now, when you go with lock shipping or mirroring, that is a different story. That's why I asked. In replication, typically when customers do reporting, usually as a better option, as the best option. If they want to offload reporting, replication is probably the best option to offload it and get near real time because of course replication is asynchronous and you could potentially be a few seconds behind. But outside of that, replication is the best because it does allow you to actually access a database at will as replication is running and users are running at it as well, because it just becomes just another user. Does that answer?
I think that should be good. Natasha, did that help? Look for the end there. Yes, very much. So thank you, Ross. All right, there are a lot of questions. We have time just for another one or two. We are a good 4 minutes over.
You can send it over, and I could answer them if you want to send the other ones over.
Absolutely, I will do that for you. So we'll pass your questions on to Ross. But before we go, we'll ask one more here before we wrap up. This one goes out to Kuljit, and this is: can we have clustered server on the mirror server?
Can you have a cluster server on the mirror server? So let me see if I can send out. I could visualize. You have a mirror, and you could cluster, and you cluster the mirror. Yeah, you could cluster. You could cluster the mirror. You could have. In fact, if you look at some of one of my example, there was a mirror. You could actually have a DR across two sites and have clusters on both sides. That's a solution that would work too. Does work. And so you have a principal on DR1, DR site 1, and a mirror on DR2, and you have clusters on both sides. That's a valid configuration. So yes, you could.
Excellent, excellent. All right, and here's, you know what, I said the last question, but this one I know would be important to the audience. This one's from Stephen. Clusters seem to have some drawbacks. What method would you consider as the best overall?
Drawbacks. It depends what you mean by drawbacks. Clustering is one of the ones we tend to use the most. Here's one of the problems I run into with customers about clustering. Clustering has come a long way. So if people have, let's say, have experienced clustering way back in times, like Windows 2000 clustering, they might have some bad experiences with that, and maybe and kind of think that's the norm. But clustering has come a long way. Clustering in 2008 is a very robust solution. I tend to actually go with it first because of the virtual name, virtual IP address abstraction, which makes failover very smooth, and also because it supports it actually clusters the whole instance of SQL Server. So I don't find that as any drawbacks with it. I'll be very comfortable using it, but I do know this. There's some customers that became very accustomed using different other solutions, let's say mirroring or log shipping, and build their expertise around those. And are using it very happy, and they're very happy with it. They have the skill set, they have the infrastructure, and so they use it more than something else. But if I have to go with HA, I will go with clustering first. In addition to that, clustering gives you the capability. In 2008, you have the validation, clustering validation to set up clustering. There's a lot of functionality that they put in versus was not really available back in 2000 at times, Windows 2000.
Yeah, it's come a long way since then, right? Yeah,
Yes.
I should have asked Stephen what version of SQL Server you're running.
Yes.
But anyway, all right. So Ross, I want to thank you a ton for spending time with us in the community this morning. I hope everybody enjoyed it and got something out of it. I know a few people who hung out. Apologize for the audio issues. What did happen there? Did the microphone come unhooked or something? Do you know?
In my case, no, nothing happened.
Oh, okay.
I just saw the webinar say connection lost.
Oh.
Unless I lost wireless connection, but I didn't think. No, I didn't lose wireless connection either because the slides were moving. It seems like everything else was working fine.
Okay.
So I don't know. I didn't lose anything here. Everything's still connected.
It can happen. It can happen. All right. Well, anyway, guys, it's about 10 minutes over the time, so we do have the questions. We'll get them over to Ross. We're going to have the recording up either tonight or tomorrow on the website at pragmaticworks.com. Click webinars. Mm-hmm. They're all in there all the way back to March. So, Ross, again, thank you, and I'll post the slides as well tonight as well. So, thank you again, Ross.
I'll send you slides right now. Thank you very much.
All right, perfect. We're going to end the webinar now. Thank you, everyone. Bye-bye now.
Bye.